In this video, we're going to take a look at the highest level of understanding of these log graphs, and that is trying to find the equation of a log graph simply by looking at it. Now, we've done this before with other kinds of graphs, and hopefully you'll remember that this involves asking yourself a series of questions, and as you're answering those questions, you're gradually building the formula for the graph that's in front of you. So it's no different with logarithms, although there are a few trickier steps for logs. See, with like a parabola, there's only one basic parabola graph, but with logarithms, there's multiple different basic log graphs depending on what the base is. So the base is going to be another thing that we have to figure out in the process of coming up with the formula here. Okay, so the very first step, now I'm going to go through these notes. We've got 4 steps in this process, and not only am I going to go through the notes, but I actually have an example side by side with it that we can do and look at to help us try to come up with the formula of this graph on the right, and then we'll do multiple more examples of this. So number 1 says, the first thing you want to do is identify the direction of the graph. This will determine if there's been any kind of reflections. So let's go through some different options here. If you're seeing a trig graph that's going up and to the right, that's normal. And that means there has not been any kind of reflection either over the x or the y. Okay, the next option might be something that looks like this, where the graph is going down and to the right. This means you have a reflection over the x-axis, and therefore you would need a negative out in front in your formula. The third option would be maybe you see a graph that's going up and to the left. Okay, that would be a reflection over the y-axis, and therefore you would need a negative directly on the x inside of your function, but I would be careful to factor it out so that it's not affecting the horizontal shift. And the last option, which is the most complicated, is if you see a graph of a log function going down and to the left, this means it's been reflected in both axes. So it's flipped over the x and the y. It's backwards and upside down. And that means you would need a negative in both positions, out in front and also inside. Well, if I look at the graph that I have over here, it is doing exactly what a log graph is supposed to do. It's going up and to the right. So this is a normal log graph. So I'm going to start to build its formula. Y equals some log of x. I'm not going to put a negative out in front, and I'm not going to put a negative inside. Okay, second thing we want to do is we want to identify the vertical asymptote. This is going to tell you about the horizontal shifting that has occurred in your problem. So in this problem, I can see that my graph gets really close to this vertical line that I just drew. That vertical line's equation is x equals 2. And as we've learned from our previous studies, the only kind of transformation that you can do that changes the vertical asymptote is horizontally shifting left or right. In this case, we happen to be moving to the right, so that means we're going to have inside the parentheses x minus 2. Okay, third step. From the point on the graph that is 1 unit horizontally from the vertical asymptote. So my vertical asymptote is x equals 2. I now want to look at an x value of 3 because we're moving to the right. So I'm talking about this point right here. That point is exactly 1 unit away from the vertical asymptote. This point should normally be sitting on the x-axis. It should be your x-intercept. If you think about a normal log graph, 1, 0 is 1 unit away from the vertical asymptote. That's normally your x-intercept. Well, if it's not your x-intercept, if it's not sitting on the x-axis, that's going to tell you about any kind of vertical shifting that has happened. And since that point is 1 unit above the x-axis, I can tell that this log graph has been moved up 1. So I'm going to be putting a +1 on the end. So if it's not sitting on the x-axis, that tells you how much vertical shift there was. So from the x-axis to where it is, it must have been moved up 1. Fourth and final step. This is going to be the hardest one because this is where we determine what the base of the logarithm is. Lastly, I need you to go 1 unit up, unless the graph is upside down, then you would want to go 1 unit down from the point that you found in step 3. So this point that was 1 unit away from our vertical asymptote, I want to go up 1 unit from there, because my graph is normal. It's going up and to the right. And I need you to measure the horizontal distance between the vertical asymptote and the graph. So from here to here, that's 2 units. That is going to represent the base of your logarithm, because if this graph were normal, if that point was sitting on the x-axis, this would represent a y value of 1. And whenever you raise something to the first power, that tells you what its base was. So a base to the first power is equal to the base. So this horizontal distance between your vertical asymptote and your graph tells us what the base is. So this happens to be a log base 2. Whenever we're doing these type of problems, I am not going to put any kind of dilation on it. So no vertical dilations, no horizontal dilations. So you won't have to worry about there being a multiplying factor out in front, nor will you have to worry about there being a multiplying factor inside directly on the x. So we're going to keep it simple, no dilations in either direction for these type of problems. Okay, so the rest of these notes today are going to be to keep repeating that process until hopefully it becomes easier and easier for us to understand. So I've got this graph of a logarithm, and our job is going to be to try to figure out the equation for it. So step number 1, take a look at the general shape of the graph. What I'm seeing in this picture is this graph is going down and to the right. That means this graph of a logarithm is upside down. So I know I'm going to have a negative out in front of my logarithm. It's upside down. It is not backwards, so I don't need a negative inside, just upside down, so I need a negative out in front. All right, second step is to find your vertical asymptote. So this vertical line right here represents my vertical asymptote. Let's try to figure out what its formula is. We are 1, 2, 3, 4, 5, 6 units to the left of the y-axis. So this must be x equals -6. And the only reason that the vertical asymptote would be all the way over here is because our graph has been moved 6 units to the left. So that now tells me that inside of my parentheses, I'm going to need an x plus 6 to get it to shift to the left. Okay, third step. You now want to find the point that's 1 unit away from the vertical asymptote. So the point that is 1 horizontal unit away from the vertical asymptote is right here. That point should normally be sitting on the x-axis, but it's not. It's way down here. So how did it get down here? Somebody must have moved this graph down 3 units, and that means I'm going to need a -3 at the end of this formula to represent the downward movement. Okay, last step, and this one's the trickiest. From that point that was 1 unit away from the vertical asymptote, normally I would want you to go up 1 to measure for your base, but because this graph is upside down, I need you to go down 1 unit and measure the horizontal distance between the graph and the vertical asymptote. So basically I need you to measure this distance along this line. That's going to be 1, 2, 3, 4, 5 units. That tells me that this logarithm has a base of 5. So this is log base 5. All right, let's try our next problem. Again, we're just going to keep going through these steps until it becomes easier and easier for you. Here we have a picture of another log. First thing we do is we analyze the shape. So in this particular graph, what I'm looking at is I'm seeing the graph going down and to the left. That means that this log graph is both upside down and backwards. So we're going to need a negative out in front of our logarithm, and we're going to need a negative inside. I strongly recommend when you put that negative inside that you put an extra set of parentheses to have that reflection over the y-axis factored out. The next thing we want to do here is we want to analyze where our vertical asymptote is. So I just drew our vertical asymptote in red, and that would have the formula x equals 4. And the reason that the vertical asymptote would be that far over to the right is because somebody moved the graph 4 units to the right. So that means inside of my parentheses, I'm going to need an x minus 4. The next step is to find the point on the graph that is 1 horizontal unit away from the vertical asymptote. So that point is right there at 3, 2. And that point is supposed to be sitting on the x-axis, but it's not because somebody moved this graph up 2. So I need a +2 on the end of this formula to represent the upward movement. And last but not least, If this graph were normal, I would go up 1, but because this graph is upside down, I want to go down 1 from there, and I want to measure the horizontal distance between the vertical asymptote and the graph. And I can see that that's 1, 2, 3 units. So that tells me the base of this logarithm is base 3. So your full equation for this graph is y equals negative log base 3 of parentheses negative parentheses x minus 4, and then a plus 2 after all those parentheses. All right, last example in the notes is this one. Again, we start off with looking at the general shape. Normal log graphs go up and to the right. This graph is going down and to the right, which means this log graph is upside down. So we're going to need a negative out in front of our logarithm. Okay, the next thing I'm going to look at is the vertical asymptote. And for this problem, the vertical asymptote is x equals negative 1. That means this graph has been shifted to the left 1. So the way that we do that is by adding 1 directly onto the x inside of the logarithm. Okay, the next thing we're going to do is find the point that's 1 horizontal unit away from our vertical asymptote. And even though it's sitting on the y-axis, remember that point should have been sitting on the x-axis. So what must have happened is somebody must have moved this graph down 3. So as part of my formula, I'm going to need a minus 3 at the end. And then again, if our graph was going in the normal direction, upward, we want to go up 1 from there. But because this graph is headed downward, we want to go down 1 from there and measure the horizontal distance between the graph and the vertical asymptote. And I can see that that's 4 units. So that means this one has a base of 4. Okay, so now that we know the steps involved in this process and we've done a bunch of examples for practice, you're now ready to try the homework for tonight, which is going to ask you to find the equation of log graphs.